Hi, I'm an old guy and I do maths, and today we're looking at yet another example of a truncus, and this one has some more complicating features compared to some of the others we've looked at. In this case, both asymptotes have moved. The asymptote that was the y-axis has now moved to x equals -2 because of this. It's moved 2 to the left. And the asymptote that was the x-axis has now moved down 3 to y equals -3. A consequence of that is that we have this, and this point to try and figure out. And what we'll start with is this point, because it's probably the easy one, in which case we just put 0 into this equation, and we get 1 over 0 plus 2 all squared minus 3 equals whatever it does. So let's work this out. So that's 1 over 2 squared, which is 1/4 minus 3, and that equals -2 and 3/4. So this point here is -2 and 3/4. And that's its value there on the y-axis. You'll notice that this is not drawn to scale, but it's a fair representation, I think. So just let me go through that again quickly. 2 squared is 4, so that's 1 over 4. 1 over 4 minus 3 is -2 and 3/4. That's our point there. Now, these ones here require a bit more work, and I'm going to set them up on this page, and then I'll probably have to roll over a page and do some more working. But the setup is this. We need 1 over x plus 2 all squared minus 3 to equal 0. Now, the easiest way in which to deal with this is to multiply both sides by x plus 2 all squared, and we get 1 minus 3 into x plus 2 all squared equals 0. If we expand that, we get 1 minus 3 into x squared plus 4x plus 4 equals 0. And if we tidy that up some more, we get, I put the 1 over here, and we get -3x squared minus 12x minus 12 plus 1 equals 0. And so we have -3x squared minus 12x minus 11 equals 0. We have that to solve for 0. So how am I going to do that? Well, I'm going to use the quadratic formula. I don't want to be completing the square, so I'm just going to set this page to one side, and hopefully we can just see what it is in that top left-hand corner, what it is that I have to solve. So let's set this up. -3x squared minus 12x minus 11 equals 0. Okay, so let's pop that into the quadratic formula and get going. Okay, so the quadratic formula, for those of you who don't remember, -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's fill that in. -b is 12 plus or minus the square root of b squared, which is 144, minus 4 times 3 times -3 times -11, 4 times -3 times -11, all over 2a, which is -6. So there's a clue already here as to how these points of intersection will center around the asymptote. Just let me remind you what the vertical asymptote was. It is x equals -2. So if we divide 12 by -6, we're going to get -2. So that's a very good start. Things are going well. Okay, tidy this up. We get 12 plus or minus the square root of, now, 144 minus 12, or plus, sorry, 144 minus 4 times negative 3 times negative 11 is 144 minus 132, which is 12. So this thing does have solutions. That's great. All over negative 6. Now, some tidying up. Let's bust this up into parts. So this makes things a little clearer. The negative 6 is dividing all of this, so we can just bust it up like this. So that gives us negative 2. That's our asymptote. And just to come back to this a second time, there is our asymptote at x equals negative 2. Okay, now let's tidy this up. Plus or minus 2 root 3 on 6. Okay, now can we do something about this? Well, yes we can. This is equal to negative 2 plus or minus 1 on 3 root 3. Now I'm going to simplify this a little bit more. It's another way of putting this is 1 times root 3 on 3, or root 3 on 3, which is the rationalized form of the following, or is a rationalized form of the following: negative 2 plus or minus the square root of 1 on 3. And that is our answer. You can check, you can get out a calculator and you can check that that value, and that value are actually all the same. So what does that mean for us? Well, it means that this value in here is negative 2 plus root 1 over 3. And that this value in here is negative 2 minus root 1 over 3. Or you could just write 1 over root 3 if you wanted to. It's up to you. It's just another way of putting it. So that is the entire process. There's quite a bit of work once you start getting into truncus equations where you've got an asymptote below the x-axis, and you have to work out a couple of points of intersection. Very often you'll have to resort to something like the quadratic formula. I would not have chosen to complete the square in this case because it's just a pain. But anyway, that's our answer: negative 2 plus or minus root 1 over 3, or if you want to write it as 1 over root 3, still plus or minus, because the square root of 1 is 1. Okay, thank you very much for watching. I hope that this all made sense and it was useful. If it did, please like and subscribe, and I'll see you next time. Bye.